Hello, everybody. I'm back. What I'd like to do now is talk about packages for Python. One of the things that Python is great about is it allows us to download lots of material that we don't have to write. So I sent you a note on this, but just to show you some of the ideas, I'm going to Well, I thought I was going to, pardon me. I have to do something else first. I'm going to copy the address I gave you for downloading. I'm going to copy it in here, and then I'm going to run it. This is the material I'm talking about. This is a science package that's used for data analytics, I believe, for artificial intelligence, for almost anything. And it has lots of little pieces to it. Scipy is the main one. NumPy is one that we'll be using. Math plotting library is very useful. I'll do some of that too. Now, to download, you just go here and say install. And after you say install, it'll give you some information on how to do it. And one of the ways is pip. That's the way I used, and it seemed to work perfectly. This is the line you have to use. But now you have to get to that line. Down in the bottom of your screen, which you can't see, next to the big button on the bottom, at least on a Windows, there's a type here to search box. If you type in that box and just say CM, you'll see prompt, command prompt, and that brings up this area. That is where you type this item in. It worked for me. I hope it works for you. I think further down they talk about how to do it on a Mac, but I don't have a Mac to try. Now, the next thing I want to say is once you get it hooked in, we can start talking about some of the things you can do with it. First of all, I'm going to bring up Python so I can show you what I've done with it. Okay, I think it'll work. Now, if you look here, there are pieces of this that you didn't see before. I have managed to somehow make the screen appear differently. The reason I've done that, how I've done it, is that I have clicked on View here, which it won't let me do. And when I click on View, it gives me a choice of different views I can use. Let me move this out of the way. Maybe out. Yeah, now I can click on View. And when you click on View, you're going to go to Windows Layout. And then on the Windows Layout, you're going to see MATLAB Layout. When you do that, you'll get a much better screen. You'll get a lot more. It's a lot bigger. It has more windows. It's kind of a nice screen to work with. I'm not having much luck. I'm trying to expand this, and it doesn't want to do it. See if I can expand it on this side. No. I'll move it over. You can see there's the screen. There's more screen to it. It's kind of nice. Now, let's run some programs with it. So for a minute, I'm going to have to see if I can minimize some of this. It isn't doing it, so I'll have to put it down and get what I want to use. Here's my first example. And I'm going to put it in, and we're going to see how it works. So I'll go back to here. Well, I have to put that down first. I didn't do something. Now let me go back. And I'm going to start with a new file. And I'm going to paste this in. Now, traditionally, the way people talk about using this is when you bring it in, you import numpy, and the P might be capitalized, and you give it the nickname or the alias NP. It makes it easier to work out. Now, I actually brought in too much. I brought in the answer. But when I run this, what I'll get, nothing happened. Oh, you can't see it. There's what I got. NumPy gives us pi and e as these two numbers. So one thing this does is have constants. Constants for some of the more important mathematical constants. Now, let me try a second example for you. This is one that you might find a little difficult. The way this system works is it works using n arrays. And I'm going to show you an example of an n array right now. Let me bring this back, and I'll just put it right at the bottom of this. I have just defined an array. What I'm defining is actually a tic-tac-toe board. You use np.array, and then in the parentheses, you put each row of whatever you're going to be creating. You could even go deeper. You could use 3-dimension. I'm saying a bracket. This is my array. The first thing in my array is a 3-element row. The second thing is another 3-element row. Then I have the final 3-element row, another bracket, and then I close that. Now that's how you define arrays. Once you define one, you can print it out just like everything else. And if I print it, you'll see that it produced it just as an array. So you can create very easily whatever kind of matrices, arrays you want. Now let me go to another one, if I can get to it. I'll use this. And I'll import this for you. We have the trigonometric functions. But as with most trigonometric functions, it has to be in radians, the angle. So radians converts 90 to pi over 2. Both of these are getting the sine of pi over 2. Notice the NP in front of it. When I run it, 1 is the sine of 90 degrees. So you have all these nice trig functions. You have other functions too. Next, polynomials. Now this is a little bit stranger, but let's see if we can do it. I may have to do something Yes, I'm going to have to do something a little different here. I may even have to look it up to see how I do it, because I'm not sure I remember, but I'm going to try. I think I'm going to go back to this one. No. Let me bring up a file. File, open. And this is the one I worked on yesterday. See if I can find it. I thought it said scipy. If I can find it. Again, I have to get my picture out of the way. I don't see it, so I'll just have to wing it at the moment. Let me see if I have it. No. All right, I'm going to close that. Go back to here and see if I've got what I want in here. Well, I'm going to try it as is. I think it's going to fail, but we're going to see in a minute. So I'm just going to go back to where I was, if I can get there. Let's see if I can find what I'm looking for. Doesn't want to show it to me. You can see I have a fair number of files here. Oh, there it was, temp. I think that was it. No. All right, I'll start with a new file. Now, as before, I have to import numpy as np. And then I'm going to try to run this program, which involves polynomials. The reason it's green is because I'm inside the comment. So I'm going to get rid of all of this. I'm just going to copy it. Well, should be okay. I just have to get rid of this. That's what I have to get rid of. And put in the 3 quotes. All right, now it's there. Now I misspelt numpy, but that's normal. So let's see what happens when we run it. I was right. Import module not found error, no module. I guess I have to spell it properly. I'm surprised. I didn't think I had to. I think I have the right words there, don't I? Yep, now it's okay, so let's run it. Well, it worked. What I did was I created a polynomial. If you remember polynomials from high school or wherever, they're just things like x squared plus 2 or 3x squared plus 3x cubed plus 4x plus 5, something like that. I put in a bracket inside the parentheses the coefficients for the powers, and then all I do after that is I can print them. I can put the derivative, and I even took the second derivative because you can go poly and then which derivative you want. Now, the results, you can see it tried to write them out in pretty nice form. It didn't make it perfect, but it tried. The last thing I would like to show you is MATLAB, the plotting. The plotting is amazing. It works pretty well, and it works fairly easily once you get the hang of it. But I warn you, there's a little bit of a curve here in learning it, and I'm still sort of learning some of it myself. So let me try this. I'm going to go back and create a new file, and I'm going to print this in. Now, Matplotlib is another part of what you load in. I'm running out of time, so what I'm going to do is run it, and I'm going to take this over and show you the kind of thing it gives you when you do this. That's a quadratic. The formula for that is out on the file I sent you yesterday. That's all I have time for. What I'd like you to do is try to make a plot of something.